Hello students, welcome back. I am Rinkesh sir and today we'll continue with exercise 10.2 of chapter number 10, that is vector algebra. Let's start with question number 1. Question number 1. Compute the magnitude of following vectors. So first A, let me represent in simple form. The coefficient of I is 1, coefficient of j is 1 and coefficient of k is 1. The magnitude of A will be equal to under root of 1 square plus 1 square plus 1 square, that is under root of x square plus y square plus z square. So it is root 3. For second, coefficient of I is 2, j is minus 7 and k is minus 3. So magnitude of B will be equal to under root of 2 square plus minus 7 square plus minus 3 square. So this will be under root of 2 square, that is 4 plus 49 plus 9. Okay, so it's 49 plus 9, 58 plus 4, 62. So this will be equal to square root of 62. This is the magnitude of vector B. Now C, this will be equal to 1 by root 3, 1 by root 3 and minus 1 by root 3. Okay, so magnitude of C will be equal to under root of 1 by root 3 square, that is 1 by 3, 1 by root 3 square, that is 1 by 3, and minus 1 by root 3 square, that is also 1 by 3. This will be equal to 3 by 3 and root 1. So magnitude of C will be equal to 1, that is the unit vector. Okay, so this was about question number 1. So just note it down. Now let's move to the next question. Write two different vectors having same magnitude. Okay, so you can write like vector A 3i plus 4j plus 1k, or B, just this numeric value must be same. It can be in any direction like 4i minus 3j plus 1k. Both are different vector. Magnitude of A under root of 3 square, that is 9, plus 4 square, that is 16, plus 1, so that is root 26. And magnitude of B, that is 4 square, that is 16, minus 3 square, that is plus 9, plus 1 square, that is also root 26. So vector A and B, these are the two different vectors which are having same magnitude. Okay, then the third one, write two different vectors having same direction. If I take vector A as 1i plus 2j plus 3k. If I multiply this by 2, that means 2i plus 4j plus 6k. Then both will have same direction. Let's find out the unit vector. That is vector 1i plus 2j plus 3k upon under root of 1 square 1 plus 2 square, that is 4, plus 3 square, that is 9. So 1i plus 2j plus 3k 1 upon 9 plus 4, 13 plus 1, 14, root 14. Okay, so if I take unit vector for B, because the unit vector only shows the direction, 2i plus 4j plus 6k upon under root of 2 square, that is 4, 4 square, that is 16, and sorry, yes, 16. So that is my, yes, not my mistake, and 6 square, that is 36. So I can take 2 common in the numerator, so it will be 1i plus 2j plus 3k. And in numerator it's 36 into plus 16, 36 plus 4, 40, 40 plus 16, that is 66. Sorry, 56. So that is root 56. Okay, so we know that 14 fours are 56, so that can be root of 14 into 4. Square root of 4 is 2, so it's 2 root 14. So 2 root 14 Okay, so 2 ones are 2 ones are. So it's again 1 by root 14, 1I plus 2j plus 3k means both are having same unit vector means same direction. But both the vectors are different. Okay, so this was about question 2 and 3. So just note it down. Question number 4. Find the values of x and y so that vectors 2i plus 3j equal to xi plus yj. So here it is given that 2i plus 3j equal to xi plus yj. Now two vectors are equal if their coefficients are also equal. Means here two vectors are equal. That means the coefficient of I and j will be equal. That means x equal to 2 and y equal to 3. Okay. Next, question number 5. Find the scalar and vector component of vector with initial point 2, 1 and terminal point minus 5. So let's take the initial point that is having position A as 2, 1 or 2i plus 1j. And the terminal point B with position B that is minus phi 7 or minus phi I plus 7j. Okay. Now, if I want to find out the vector with initial point and terminal point, initial A and terminal B, then that must be equal to vector AB from A to B. And its formula is B minus A. So it's minus phi I plus 7j minus 2i plus 1j. This should be minus pi I minus 2i. So minus 7i. 7j minus 1j. So it will be 6j. Okay. Now the scalar component means the coefficient of I and j. So scalar component that will be equal to minus 7 and 6. And vector component with the direction, so that will be equal to minus 7i and 6j. Clear? This was about question 5. Next, C. Three vectors are given and you have to find the sum. It's vector A plus vector B plus vector C. What I need to do? I minus 2j plus k plus minus 2i plus 4j plus 5k plus c I minus 6j minus 7k. So for vector addition, we need to add the x component, then we need to add y component, and then we need to add z component separately. So first x component, 1i minus 2i, that is minus I, plus I. Okay, so that will be equal to 0i. Now minus 2j plus 4j, that is plus 2j, minus 6j, so 2 minus 6, that will be equal to minus 4, so minus 4j, and plus k plus 5k plus 6k minus 7k, so that will be equal to minus k. This a plus b plus c 0i, so no need to write it down, that will be equal to minus 4j minus k. Clear? So this was about question 4, 5 and 6. So just note it down. Now let's move to the next questions. Question number 7. Find the unit vector in the direction of vector A equal to I plus j plus 2k. So here vector A is given as I plus j plus 2k. Okay. So now the unit vector in the direction of this will be equal to vector upon its magnitude. So it will be I plus j plus 2k. And its magnitude is under root of x square plus y square plus z square. Okay, so that will be under root of I, that is 1 square, 1. Coefficient of j, 1, 1 square, 1. Coefficient of k, 2, that is 2 square, 4. So this will be equal to 1 by root 4 plus 1 plus 1, 6. I plus j plus 2k. This is the unit vector in the direction of vector A. I can also write down in this way. 1 by root 6i plus 1 by root 6j plus 2 by root 6k. Clear? This was about question number 7. Let's see 8. Find the unit vector in the direction of PQ, where P, I will write it as 1, 2, 3, and Q, I will write it as 4, 5, 6. So vector PQ will be equal to final, that is terminal point, minus initial point. So it's 4, 5, 6 minus 1, 2, 3. So 4 minus 1, 3. 5 minus 2, 3. And 6 minus 3, that is also equal to 3. Okay. So now the unit vector, let's represent by n cap. This is in the direction of PQ will be vector PQ upon magnitude of PQ. So vector PQ 3, 3, 3 upon under root of 3 square plus 3 square plus 3 square. Okay, so it's 3, 3, 3 upon 3 times 3 square. So 3, 3, 3 upon 3 times 3 square, that is 3 root 3. So solving it, I will get 3 by root 3, 3 by root 3 separating it, or else let's take 3 common in the numerator. So it will be 3 and 1, 1, 1. Okay, so 1 by root 3, 1 by root 3, 1 by root 3, separating it. Or 1 by root 3 I plus 1 by root 3 j plus 1 by root 3 k. Clear? So this is the unit vector in the direction of vector PQ. So this was about question number 7 and 8. Just note it down. Now let's move to the next questions. For given vectors A, that is 2i minus j plus 2k, I am representing in a simple way. 2 minus 1, 2, the coefficients. And vector B, that is minus 1, 1, minus 1, means minus I plus j minus k. You have to find out the unit vector in the direction of A plus B. So first let's find out A plus B. That will be equal to 2 plus minus 1, that is 1. Minus 1 plus 1, 0. And 2 plus minus 1, again that is 1. Okay. What I did the x component, y component and z component. Okay. So this is vector a plus b. So if unit vector n in direction of a plus will be equal to vector a plus b upon magnitude of a plus b. So 1, 0, 1 upon root of 1 square, that is 1, 0 square, that is 0, 1 square, that is 1. So 1, 0, 1 by root 2, or else it will be 1 by root 2 I, 0 by root 2, that is 0, no need to write down, and 1 by root 2, that is k. Okay, so the unit vector in the direction of a plus b, that will be equal to 1 by root 2 I plus 1 by root 2 k. This was about question number 9. Let's see question 10. Now question 10, it is given, find the vector in the direction of phi I minus j plus 2k. So let's the vector AB. Phi minus j means minus 1 plus 2k means 2. Now you have to find out, see, the vector given is a, and you have to find out the vector which is in direction of a and has magnitude of a. So first we will find out the direction. How to find direction? Unit vector. So where is the value of unit vector? 1. So when I will multiply it by 8, its magnitude will be 1 into 8, 8. So first let's find out the direction, that is unit vector. So unit vector A will be equal to 5 minus 1, 2 upon under root of 5 square, 25, minus 1 square, 1, and 2 square, 4. This will be equal to 1 upon root 30 into 5 minus 1, 2. This is unit vector A. So the vector B, let's take B which is in the direction of A and having magnitude 8. So vector B will be equal to, or required vector will be having magnitude 8 units, direction of A. So this will be 8 by root 30, 5 minus 1, 2. Okay, so or else I can also write it down in other way, like 8 by root 30, 8 into 5, that is 40 by root 30 I, minus 8 by root 30, 8 into minus 1, minus 8 j, 8 by root 30 into 2, that is 16, plus 16 by root 30 j. Clear? So this is the vector of magnitude 8 units and the direction of vector phi I minus j plus 2k. So this was about question number 9 and 10. So note it down. Now let's move to the next question. Question number 11. Show that the vector 2y minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. So let first this be vector A, 2 minus 3 and 4. Vector B, this will equal to minus 4, 6, minus 8. Now see, if I take minus 2 common from vector B, I will get minus 2 into 2, minus 3 and 4. Now this is vector A. So I can write it down, vector b equal to minus 2 and into vector a. Now see, I had multiplied vector a with scalar, I got vector b. That means a and b are collinear. See, the direction is opposite because the scalar is negative. If it was positive, then both will have same direction. But in this case, the direction is opposite. But they are collinear, right? Collinear vectors means say both must be parallel. Either the direction must be same or opposite. Hence, B and A are linear. Okay, this was about question number 11. Now let's see question 12. In question 12, you have to find out the direction cosines of vector I plus 2j plus 3k. So let's take this vector as 1, 2, and 3. Now see, if you want to find out the direction cosine, the shortcut is find out the unit vector and the x component, y component, and z component of that unit vector are the direction cosine. Okay, so find out unit vector A, that is equal to 1, 2, 3 upon square root of 1 square, that is 1, 2 square, that is 4, and 3 square, that is 9. So 9 plus 4 plus 1, that is 14. So it will be 1 by root 14, 2 by root 14, and 3 by root 14. Okay, so this is the unit vector. Hence, the direction cosines are 1 by root 14, 2 by root 14, and 3 by root 14. Means cos alpha 1 by root 14, cos beta 2 by root 14, cos gamma 3 by root 14, where alpha, beta, and gamma is the angle made by this vector with respect to x, y, and z axis respectively. Okay, so whenever you are asked to find out the direction cosine, find out the unit vector and its x, y, and z component are the direction cosines. Okay, so this was about question number 11 and 12. So just note this down. Now let's see the next question. Find the direction cosines of the vectors joining point A and B directed from A to B. Okay, so first we need to find out vector AB. That will be equal to B minus A, means minus 1, minus 2, 1, minus 1, 2, and minus 3. Minus 1, minus 1, minus 2. Minus 2, minus 2, minus 4. 1 minus minus 3. So that will be equal to 1 plus 3, 4. So I got the vector AB, means the vector joining point A and B directed from A to B. So now for direction cosine, what is our shortcut? Find out the unit vector. So unit vector will be equal to minus 2, minus 4, 4 upon under root of minus 2 square, that is equal to 4, plus minus 4 square, that is equal to 16, plus 4 square, that is again equal to 16. Okay, so it's 16 plus 16, 32 plus 4, 36. So minus 2 minus 4, 4 upon root 36. So this is equal to minus 2 minus 4, 4. Root 36 is 6. So the unit vector is minus 2 by 6, minus 4 by 6, and 4 by 6. This is equal to minus 2 by 3. I will reduce it into minus 1 by 3, minus 1 by 3, and sorry, 2 by 3, and 2 by 3. Okay, I got the unit vectors. The direction cosine will be the x, y, and z component. So the direction cosine of vector AB directly from A to B is minus 1 by 3, minus 2 by 3, and 2 by 3. Okay, so direction cosides of vector AB are minus 1 by 3, minus 2 by 3, and 2 by 3. Clear? So this was about question 13. So just note it down. Okay, students. So that's it for today. Thank you.